Let's spend some time trying to change a repeating decimal into a fraction. In the notes we say a few things about real numbers, rational numbers, irrational numbers. What I want to review here from that is that anytime you're given a real number with a decimal that repeats or stops, you can write it as a quotient of two integers, provided you're not dividing by 0. So what I want to be specific about here is if I gave you the number 0.9 repeating, what's that equal to as a fraction? If I was to take this number and try and place it on a number line, where would it go? 0.9 repeating really seems like it should be to the left of 1, and it should be to the right of 0.9, to the right of 0.99. I could keep on going here if I was to zoom in. So how close should I place 0.9 repeating to 1? And I'm really hoping by writing it as a fraction, I can see that with a little more clarity. Well, with this geometry here, the idea of putting it on a number line, I'm not exactly certain what to do. So I'm going to employ some algebra, and I think this is an important thing for students to start to take advantage of different tools to solve a problem. So with algebra, a lot of times we like to manipulate equations, we like to take unknowns and work with them. So if I put x equal to 0.9 repeating, what would happen if I took 10 times x? Well, it's just going to move the decimal over and I get 9.9 repeating. Okay, that's not really anything too astounding. But wait a second here. If I really wanted to figure out a fraction that would represent 0.9 repeating, I could stack a couple of equations and subtract down. What it is by stacking those equations, these 9s that repeat, I could, as long as they're lined up, subtract them away. So 10x equals 9.9 repeating, x equals 0.9 repeating. If I was to subtract downward, I obtain 9x equals 9, or x is exactly 1. So back to this earlier question I had, if I'm trying to place 0.9 on a number line, where do I need to place it? Right at 1. There is no space between 1 and 0.9 repeating. Sometimes students find that to be a little bit strange. Got all these 9s here. Shouldn't that be less than 1? Well, this notion of a limit, something we will spend a lot of time studying in our first unit here, comes into play. What's the limit of letting those 9s continue to be repeated? It's 1 when you're all said and done. Another important idea that I want you to think of about this, there's more than one way to represent the number 1. The representation is not unique in this situation, which seems a little odd. So now that we've had one experience here with expressing a repeating decimal as a fraction, let's practice one more time, and I think you'll be good to try some on your own. So let's say we put, let's say we're given the number 0.45 repeating. How could I write that as a reduced fraction? How could I do that? I know that it's going to have to be able to be done since 0.5 is a repeating decimal, but what exactly are those numbers? Let's mimic what we did over here with 0.9 repeating. First, put x equal to 0.45 repeating. Think about multiples of x. Well, 10x would be 4.545. If I was going to try and stack these and subtract like we had just a little bit ago, the 4s and the 5s aren't matching up. I wouldn't get the kind of cancellation that I had earlier. So sometimes multiplying by 10 isn't enough. You might have to multiply by 100 or 1,000, something like that. It is closely tied to how many digits are repeating. So 100x is 45.45 repeating, and I see potential here. If I was to take 100x, which is 45.45 repeating, and subtract from that x, which is 0.45 repeating, I would be allowed or be able to cancel the repeating 4, 5. I get 99x equals 45. A little division yields 45 99ths. Well, that's going to be 9 times 5 over 9 times 11. 5/11ths would be the fraction in reduced form that is equivalent to 0.45 repeating. So using these techniques, you can take a whole lot of repeating decimals and write them as fractions.